Okay, so we're going to do a quick one here. So it's kind of late, so I think people are probably off right now, but I wanted to do that anyway. So that is today what we're going to do is the zcoder and the episode 0.5. And so the goal here of the coder is the following. Decoder is a terminal UI. Oh, wait a sec. So sorry, it was my coder body in a way, the one of the zcoder body. And so today here, what we're going to do is we're going to do the decoder. So let me start over. I'm sorry. So today here, what we're going to do is we are going to do the episode 5 of the building of zcoder. So that is what we're going to do today. And the goal here of zcoder is to be a parallel first AI coding harness. So this is going to be zcoder can talk to any model, open source and everything. So it's not locked into one. And then you will be able to do parallel work in many ways. And the way it works here is we have this concept of workbench. And that is a very powerful context. Today, for example, I'm using ProCoder with AIPack. So I've done something else. So everything is going to be coded in Rust. And the AIPack is something coded in Rust. It's kind of generic and it has a ProCoder on top of it. And we're going to see a little bit that today. But now I want to take it to the next level. I have the concept of a workbench, and a workbench can work on a work tree. And now you can have multiple workbench working at the same time. Now, the cool thing with Rust is that Rust is very efficient at doing parallelism and everything. It's really safe. So in a way, we can build amazing parallelism with Rust in a very efficient way. There's also another crate that I am the creator of. So if you do go to crate GenAI, so this one is the one that I'm the author of, and it can talk to native protocols to many providers. We have about 25 providers, I think, at least. And it talks to all of this provider and this model, and so that allows you to kind of talk to anybody. So we're not locked into one. Today we're going to start the new test the new Flash 3.5 and to see how well it codes with Rust. So that's good. But the point here of the coding is the following. That's my approach, is that production coding, you have to code with AI. There's no brainer about that. The force multiplier is too much there to ignore. However, that is the thing that many pseudo CEO or whatever are not telling you, is that if you want to create a production application, you still need to have the steering wheel. And so that is where we are going to spend quite a bit of time on this one with Rust. And then that will be able to be force multiplied with AI. What matters is these guys here, these two guys. Okay, so that is what we're doing. Now, if you go, hey, love your content, thank you, really appreciate. Hey, step. And yeah, thank you for the nice one. I really appreciate. So today here, there's a zcoder Rust, and everything I do is always, most of the time, open source, if it's not all the time. So if you go to the zcoder here, is over there, and you have the GitHub there. Start, the more stars, the better. Already 14 is not too bad. We just started that last week or something like that, so it's pretty good, or 2 weeks ago. And that is, I don't even have a README right now, but I have something that works. So if we go to the zcoder, and so I am using, okay, sorry for the confusion. Okay. This one, I'm moving it, and that's my stuff here. Okay, so that is my terminal. So I'm using Z, by the way, now. So that is Z. I love Z. And that is Alacrity with Tmux. So that is a Tmux business. And now this is to get my API keys as the environment variable. And now we can do a cargo run. And right now the UI is very basic, but it works pretty well. And there's starting to have a pretty good coding pattern over there. So as you can see, let me do that like that. And as you can see here, we have this guy that, perhaps I should turn down the light a little bit. And this is just a prompt so far. So there's not much, but we're starting to put the thing together. Say, why is the sky red, for example, and that will send the event, and then it will do this kind of things. So that's cool things. And then we can even say, in demo dir only, we can even say, create a simple loop in Lua. Let's say Lua. Boom. And then it will create a loop here, demo dir, so it's hard-coded to go there, and then it will create that. So we have this kind of thing. So the reason why it's so fast is because for now, and obviously, we are building it from scratch. So in 6 months, 3 months, it's going to be cool because you will see the building of a full application from scratch. And so when you go there, you see the main, and you will see the executor. So that is the executor guy, which I don't know why is not there. Okay. And that is a mystery. Oh, sorry, I'm being dumb here. So one thing is we have the subcrate. We did that a couple of days ago. So it's a multi-crate application. So that is a main app. And then we have actually the TUI over there. So that is the things here, which is confusing. I think this one can get away. That was a leftover because it's not part of the clean, but move to trash here. And then if we do a cargo run, that was a leftover before. So I do quit. Here on this one, this one is funny. And if we do a cargo build, that will work. It didn't change yet. So the architecture of the TUI of this guy, it's a multi-crate. So that is a main application. And that is, we have 3 subcrates, which is a common, the core, and the TUI. And the goal of that is the following. What we want is we want that architecture. So this is this architecture. I'm going to remove the event for now. So we have a multi-crate from the start. So the big application that I've created before, is called AIPack. And this is what I'm using to do the AI coding for now until zcoder is operational. In AIPack, I didn't do the multi-crate. The benefit of the multi-crate is 2 things. I mean, it's multiple things. One is compile faster then, because when you change only one guy, the other one doesn't have to recompile, so it's faster overall. The other thing that it does very well is that it helps us, is a forcing factor to have a good code design, because now you cannot have something like TUI depend on core and core depend on TUI. So you have a good compartmentalization in a way. Why that is very important. And I remember back in the days when I was young, I was working Oracle, we had something which was email. And basically, the way that it was done is that the data and the UI was really mixed together. And once you have that, it becomes a nightmare very quickly, because all your states confused between application data state and UI state, and everything become a mess. With that architecture, well, it's harder to do a mess, because now I have the Z core that is going to be the executor and the model and the store. That will be SQLite. I mean, it is SQLite right now. But the message is still a little bit hacky. We're going to fix that today. But then after, I can have later, if I want, this guy. I can have a ZC web. And then everything will work very nicely because all my event passing and everything will work. And now suddenly I have a web interface to it, or I can have a Tori app to it. So the nice things about having the right architecture from the start is that then you can scale your application and you can have different facade of your application. So this is why when I build, and this is the power of Rust, because Rust, the typing system and the system is so well made in a way, it allows us to build clear app like a backend app in many ways, because we have async, we have message passing, the bus, or the MPSC and so on. And then we have this create business that allows us to separate responsibilities. So that is the thing that I'm a big fan of. So now, if we go back to the code here, what we're going to see is we have the exec, and in fact, this is just a leftover. This is why I got confused. So now we just have the source. The main here is say, hey, I want this core, and I want this TUI, which is just there. That basically there's an asymmetry I don't really like, but I understand, yeah, this one is good because it's just a function. And then we are starting the executor. The executor today is the one that actually does the job. And when we are creating a new executor, we have two things, which is the executor guy, which is going to do the job, and is giving us back an executor TX sender to send event. And in fact, that, and we're going to rename it a little bit, we're going to clean it a little bit. That is the executor, the command executor, is to send the command. Yeah. So now if I go to the architecture, then it's pretty cool. And I don't know why. Oh, if I go to the architecture and you're going to see that. Oops, sorry. No. That is the event model. Yeah. So right now, this one is not connected yet. So the TUI kind of sends the things, and this one sends the data back there. We don't want that. What we're going to do today is to say, hey, TUI, do this prompt. And then the executor is going to do it. And that is with the exec command. So this guy is going to do it, do the work. Then it's going to store it in the store, in the model store over there. And then it's going to send a status event to anybody that want to listen. Right now, it's going to be only one, is MPSC. So multiple producer, which is, here's a single producer actually. And then there will be, for now, a single listener. We will change that to a broadcast probably later, a little bit like this guy. This guy is a broadcaster. So every time something changes, it will broadcast a change, just the IDs. That allows you that then after, again, if you have two little facade of your app, they will get the notified. And then those guys can call the model to get it back. So people can go to the model. Yeah? This is to exec the command, but it's okay for things to add the model as long as to get the changes, they listen back and then they can read. So once you do that little ping pong, your application starts to scale very nicely and everything starts to be concurrent in a nice way. So that is the little work that you put up front, such as then after you can scale your app. So that is a goal of what we're going to do. So what we did in the previous episode here in the live, so I'm doing the lives right now because this way I have less editing pressure and, if people like it, it's great. It's a little bit longer. But the goal here is that I have these three subcrate. So the common is where we put the base of the event. So that is what we did in the previous episode. We did, and that's what I like. I like to use Crossfire. So we had a whole episode about Crossfire stuff, which is very powerful, very efficient. So it's like Flume or it's like Crossbeam, but I think it's the next generation. It's very well made and very powerful and very optimized. So we have everything. The only thing they don't have is broadcast, which is fine because we can have the broadcast from Tokyo. So that's okay. And then that we normalize that, and that then every layer have their own events as well. So in the TUI, if I click on event, that is best practices. If I click on event, I see that I have my TUI event, which is basically the event telling telling it's almost a little bit more commands than events. Yeah. So a format that I like a lot is this one. Is event is something already happening. A message is some information being sent. So usually I don't use that very well. And then the command is do something, is the action. Yeah, so this one, in fact, if we see that, is no, is an event. Yeah, so something already happened. So that is we are listening. So what we're doing here is we have the loop, TUI loop. And in the terminal UI, it's always a loop that refreshes, immediate mode. So what you want is in your Ratatouille, and we're using Ratatouille obviously because that is the best, what you want is to have only one loop, one receiver to listen to. And that is why listening to this guy, which is a TUI RX. And inside the TUI RX now, in the event, we say, oh, we start the term at the beginning and we read all of the events, the keyboards and everything, and the mouse even and so on. And then we send that in the TUI event message bus. And so this way we are normalizing all the events. So now we can have a timer, or we can have data models also sending to that event. So we will have another loop that will listen to the data model, and we'll have another type over there. So if we go to event, we don't have that yet because it's not wired. But if you go to event, I'm going to have another guy, which is going to be, and we're going to, let's put it there actually, it's pretty cool. We're going to do a model, and that is going to be a model event. So that is when the model change, because the goal here is like a video game. Yeah. What you want is a TUI to only update what is displayed. It doesn't need to read everybody. So it's listening this model events, and then they say, oh, do I display that right now? And if yes, then I need to redraw. Otherwise, what I have drawn is okay. So that is a little bit the thing that we're going to do. So, and then if we do the model event like that, okay, that's fair enough. And it should be in my core. So right now, everything is in the core. And we see that we have the event over there. So that is the exec action. That is a bus, and that is my model event. Okay? So this is my model event. And my question now is, why does this guy is not exposed? Because I do not flatten it out. So that is a module which is inside bus. And then the model event is here. And so what I want is to expose it at the mode. So I'm going to do a pub use bus, and I'm going to flatten it out. People don't need to know it's bus because it's just model. Yeah, so it's fine. So I have that. And then on the lib, I have a pub. That is good idea. The point is not wired yet, so that's why it's like this, and we do a pub model. So like that, we have a nice model things that people can see from the outside. And then we have the pub event, and that is the executor kind of thing. So in fact, that will probably go to a module executor. And then this guys is the executor event, so that will go there as well. Can almost do the refactoring right now. So let's do that actually. So you see, because I don't like it, because this is very clean, but now this one has this one. And we think that this event is the event from the ZC core, but it's not. Yeah, it should be the stuff. So what we're going to do is we're going to create that guy, and we're going to say exec. We'll just put it exec right now. And then we're going to move that there. We have model events, I think, or do we have? Oh, we have the bus over there. Model event, okay, so we'll do exec event. So we move that there. exec event. Could we have a S because we have multiple? So we have the action, which will rename it command, I think is better. And then the event, that is a status. And right now, this is what we are doing here. We coded that. Actually, the AI coded that, but we did a good job. But we don't want that yet. We don't want to pass that. So today, what is happening if we go to this architecture here is the executor, this guy to say, hey, do this prompt. And then the executor gets the prompt and then is sent back. It doesn't use this message, actually. That is going to be what we're going to do. But then it sends back the status over there with that guy's, the content. And we don't want the payload to go back there. What we want is to update the database, and then this one will probably do run done, but the UI can even listen to the model as well. So there's a very nice way here of doing that. So this is what we want to do, such as the system is really parallel in a way. So that is the trick here to make your application, which is server or CLI or Tori app, scale. Is always to have this kind of, you want to be async most of the time. In some cases, it's good to control your threads. If you have a simple app, simple CLI, sometimes you don't even need async. Yeah? But for this kind of concurrent application, async is the right way to go with. And then what you want is message passing as well, such as you can really decouple the guys. Yeah. So now when I'm going to do that, this guy is going to complain here because he say, hey, executor is not a thing. So I'm going to do an exec here. That is that guy. And then I'm going to do a pub mode exec. Yeah, I think I'm going to do that actually. This now, everything is going to complain a little bit here. And this one doesn't have any mode. So we're going to do that. Mode.rs. That is my section command that I like. So in Z, we lost the folding of regions, but I still have that because it's my habit. I don't know why. Mode exec event. This guy is not too bad. I don't really like to have this little cursor business, but that's fine. And then we're going to do the mode executor. Okay, so this is the guy that does the things. And so now this guy here is going to complain, which is normal because he say, hey, where does the event come from? So now we could say, we could put it like that. That should work. That doesn't work. That is normal because what we do is we need to flatten it out. Yeah, the reason why we want to flatten out is because we don't need the guys outside of exec to know, oh, it's inside executor, inside exec event. That is too much information. So the nice things about Rust and obviously JavaScript is the same thing, and TypeScript is you can do a pub use, and we are going to flatten it out. So right now we do a star. Sometimes you can be a little bit more tricky, picky, like this one picks exactly. And usually I don't like that. I like to go there. It's both schools. Sometimes when you have a lot of code, it's better to be cleaner. But so now we have that, and now we have these guys. Now, this is an interesting one here. So usually when I have a simple crate, like this one, for example, I have one error in my crate. That is a video that I made a while back with my error best practice. I like that a lot. And you have a mode error over there, and then you have the error.rs. So that is something I like a lot because this way every crate has their own error by default. In this case, in the ZC core, because it's going to be a relatively bigger beast, in model, for example, I have my own error. This is what I had. This one I can probably remove, by the way. No, well, I'm going to keep it for now, but this one I don't think I need it anymore. But it has its own error for the model. So I think I'm going to go the same way with the executor because in a way in the core, these guys, they are more separate kind of sub-modules. So what I'm going to do is I'm going to say, hey, I'm going to have a mod error as well. So this is things, and then this guy shouldn't be happy anymore because he will say that, which is normal. So what I'm going to do is mod error. I'm going to follow my practice and then a pub use and error. So again, I flatten it out. And what I have, I'm going to take a very simple one. I think in the common guy, I have a simple error. And I could ask Procoder to code it, but right now we're just going to take it from here. We have the error, we have that guy. And so we are going to go to this core, and we're going to have the mod error, command dot. We go there, we copy that. So that is a little bit like a template that I have, and that allows me to have the default coding, and there's a to and from string. So I've done a video about that, and it allows you to have progressive error handling, and then eventually when you mature, you delete this one, and then you fix the compile because everything should be an enum. So that is a strategy, but at the beginning, once you have that, and I use derive more, then it's very nice because you can just return strings and things flows very well. Now that's complaint because in fact, what you want is on this guy, I'm going to use, well, I'm going to put it here, but use create exec error and result. And yeah, he put it there, that's fine. And so error is here. Okay, that's good. So that is good. Now there's a guy here complaining somewhere. Okay, that's fair enough. So that is because standard couldn't be exec error. Couldn't convert error. Okay, so the UDFX doesn't convert. So that is a package that I've done to change the code. That is what is used. So that's fine. That's normal. So the nice thing is we're going to take this one, and this one we might be able to drop it because the strategy of that crate might be to say, hey, it's going to have big sum modules, and some modules will have their own error. So like this is symmetry. You don't want to cascade back up because then it creates another kind of set of tricks. So you see here that I have these guys, and I have this notation over there. So we're going to follow that. And now we're going to do something like that. And that is not external, actually. That is the C common. Yeah, kind of. Yeah. So now we have that. This one doesn't complain anymore. And we're going to have that guy that complains. We could have asked AI to do that, but this one, it's like, I want to, sometime when you do it, exec. Okay, now we're talking. And then this one, okay. Now we're talking. So that is very nice because there's a symmetry to that. And now I'm much happier. So now I go back to that guy. And this is the exec guy. And I don't have event. I don't need to have the nested stuff because now it's like, hey, this is part of the exec guys. We have the action. We go back this guy. This guy will have the model event. Oh, fair enough. Oh, because it doesn't have debug. Okay, so now we have this. It's not complaining. We still have two guys that complains. That's fair. We go back there. Exec. That is nothing. And then this one, exec as well. And then this one, that I don't like that. Oh, yeah, fair enough. The model here. And model, we're going to say, that is a model event. And we're going to say nothing for now. we cannot print because we're on the TUI business. So then it's going to put a mess everywhere. This is why we're going to add tracing. I don't know if I'm going to do it today or not, but you add tracing such as you debug into a file, and then it's pretty nice. So right now we're going to do nothing for now. Okay. So that is a whole thing. Yeah. So what we have done here, if we look at the stuff, and here I'm building these slides, this architecture things as I'm building the application in a way. Yeah. But what we have done is we have the executor loop. And so this one is a big guy that kind of work. Now we have the TUI loop. And then in the TUI loop, we have other loop. We have the, epic fail. Oh, okay, so I'm going to do that. I don't like that, but whatever. So then after here, we have the term loop, term read loop. And so this one read the things and then send it to event. So that is how we are normalizing it. Yeah. And then this guy is going to also send to stuff. So if I do L, how do I do the arrow on this guy? Sorry. I go send, I don't do arrow. Oh, they don't have a shortcut. A big fail. Okay. So this guy is going to send that to TUI loop. So every event, and this is super important, yeah, because then the TI loop will, it doesn't send to the TUI loop, it's sent to the, it doesn't send to the TI loop, it send it to the TUI RX. Okay, we're going to put it like this. So like this, the TUI loop only loops through that guy. It doesn't have to loop through other things. Then we're going to have something over there, the model as well. So that is where the model event is going to come. Model event. And then we're going to have the executor status. Exec event, which is a status. Yeah. So now the thing is, then the loop is going to decide what to do. It's going to loop, that's normalize all of these guys. And then this loop will decide, hey, what do I do? Okay. Now, the cool thing here, now the cool things about this is that this loop can be very smart and they bounce things. So let's say that model sends many events at the same time, where this loop can say, I'm going to read all of the pending events, because sometimes they might come in between a draw. And then I might have 5 or 10 model events. Well, if they're all about the same task or the same run, I can say, I don't care, I just need to keep the last one or whatever, because I'm going to read from the database anyway. And so by doing that, you can reduce by 100x the number of events and the number of loops you are doing. And so without putting back pressure, because if you put back pressure, then this guy goes slow, which is another issue. So back pressure is not necessarily bad, but what you want is to make sure that you can debounce event as well there. And then you have the best of both worlds. So that is a little bit the thing that we're doing in this stuff. So this is why we're normalizing everything with this TUI event here, which is this one. And now the event loop is going to be smart. For example, we don't need a tick. If there is another event, if there is a do, redraw or stuff, we can skip it because we are going to redraw it anyway, for example. So all of that can help a lot. So let me finish this couple of bugs, obviously, over there. That is the exec, makes sense. And that's it. I don't have any compile. This one, he complains about things. Okay, fair enough. And by the way, somewhere here in some libs I have unused, because right now I'm still building from scratch. Yeah? So if you see that, still have unused, because I have a lot of unused stuff there, and I don't like the noise. So that's why sometimes I remove the noise, and then I comment there. So if I do that, I'm going to see kaboom, 8. And then I get seasick. So boom, I do that. So now, and that is just, for exploratory dev or very early dev. And then you want the clippy stuff, because that is actually very, very nice. And that is a weird thing that you have to do, because I forbid myself to do unsafe. It's been like way too long I haven't done C or C++, so I'm not giving myself authorization to do unsafe. And that's it. So I'm okay to use libraries that do unsafe, assuming that, and it's hard to judge sometimes, but if it's popular and stuff, if people really know what they're doing, stuff, but me, I don't trust myself with the unsafe. So that is the thing. And then what I wanted to do, and now we should be able to remove. No, perhaps not for this guy. Oh, no. We should be able to remove this guy, because that shouldn't be used anymore. Yeah. That's it. By the way, derive alias is with this macro rules attribute. It's very cool. You can compose your own derives, and then I've done a video on that, so you can find it as well. So that is very cool. So again, we're doing quite a bit of hand coding right now. We're doing that. Yeah, I want to make sure that I have nothing against coding AI. In fact, we code a lot with AI, and zcoder is all about coding with AI. This stuff is more about guiding the AI. We are doing that 10%. In fact, we're doing a little bit that 10%, honestly, because if I had the best practice and really kind of everything in Rust NX, AI could have generated it. So then once you have the thing set up over there, then you can say, hey, create the spec for it. And then you can extract knowledge from spec, such as you can repeat later. But right now we're doing a little hand, and it's anyway, we love to code. I mean, I love to code Rust anyway. So now this guy is complaining types, fair enough. Okay. So now that will be obviously model. And then it doesn't have the scalar struct. This is fair enough. And that is use create scalar struct. Okay, cool. And then we have one more guy. That's fair. So now it cannot do that, yeah? So we have two choices. We can do model. We're going to do that. Okay, so it's not. I don't know if we need both, but we're going to. I think we need both. The other one still have an error, so hopefully. So that is a from, yeah? That allows me to have the from business, such as I can have the question mark in TUI for any of these errors. And then I have one more guy. Oh, where this guy is? Oh, that is a source, okay. And I think this one should be just exec at this point. Okay. So now we have done this. We're going to try it. Okay, cargo run. If you have any questions, feel free to ask. I'm always happy to answer anything on the stuff. So again, why is sky red? And then Q. Okay. Okay, so everything runs one, and I'm going to do git AC, which is add, append, and commit, and I'm going to say refactor and code clean event. Go. Don't have to be too perfect on this one. Okay, so I can push it, you can get it. And now one thing I want, I shouldn't have pushed it because now I wanted to have another one here in my, so the things that I like to do is that guy, which is event for something that has already happened. So we'll do that. Command, and this one will do a CMD for when we want to have something that does, and that is when there's some information being sent. Now, I don't like that typically, and I'm not saying all the time, because I like these two guys, because I get an event which is very cheap, and then when I get the event, I can go and get to the database. So usually I like that. I don't like to put payload in messages. And same thing with the cloud. I don't like to put big payload in messages. I either put it in a database, in a Redis, in an S3, the payload, and I put the IDs in the message bus. Because otherwise you have to scale, you create yourself 1,000x problem. And then you say, oh, how come do I need to become an expert in Kafka? Well, it's because you created yourself a problem you did not have to create. So that is, pass IDs in your messages, in your events, and then people should be able to go and pick it up. Yeah, so that is, and they could have only read access, that's fine. So that is usually what I like. Sometimes there might be some cases, that would make sense. That would make sense. So we are that. So because we are going to do the command, that could be action, but I like command better. Sometimes I don't use command because I use command for the CLI. But since they are very well separated now, the executor and the core is not about the CLI, will never be about the CLI. So it's fine to have command over there. And so I think this one, so that is I don't like. There's an asymmetry here. Yeah, exec event and then status event. That doesn't make any sense. So the type alias, I'm going to do the exec event Rx. And then I'm going to do the exec event tx. So that is a way that I like to do things. We did the video before. I like to normalize my event, the Rx and the tx on top of these guys. Those guys are using Crossfire, which is a very cool library, super fast. It's one of the fastest. I mean, if you go there, you can see crates, Crossfire. And then if you go to the Crossfire, you can see the performance here, which is through the roof. Yeah. And they have different types for different things. So these guys, they optimize a beast to the bone. So yeah, I strongly recommend these guys. They really know what they're doing. So anyway, Flume is good as well. I was using Flume before. And the problem with Flume is obviously, like the guy is a genius, and I understand, it's not a criticism at all. He's putting it in maintenance mode, like casual maintenance. So it's very nice. Yeah, if you use Flume, you don't have to migrate. It's a very robust and it's relatively maintained. Just not big features, but in a way, this kind of thing is relatively stable. So anyway, this is why I like a lot Crossfire. There were some little tricks that we've learned on the way. That was fun. So now we do that. That is the exec event. So we are happy. And in fact, I don't need that. I can do event. So again, you try to normalize oh, sorry, no. No, this is event because that is, the thing, but this one is exec event because it's the exec event and this one is a model event. So it's a nice way like that. And so I have the exec event on this one and I have the action, and we're going to rename the action CMD. So this way is Skype and obviously the type as well. So we're going, because action is, I feel it is a little bit more misleading. Okay, so I'm going to go back to my thing over there and a cargo run. Oh, fair enough. I'm going to do a save, cargo run, cargo build. Ah, sorry about that. Oh, why do you do that? Why do you get confused like that? That I don't understand why he did that. He didn't do a search replace. Okay, not sure why. Okay, good. And cargo run. And then that's it. That would be enough. Git log. Okay, I'm not going to, usually I don't do that, but git push or, okay. So now we are pretty clean. So one thing here which is happening is when we are talking to the terminal UI, one thing that is bad is we're not using our SQLite store. So right now what we have is we have a SQLite store that we implemented in the previous one. And I finished it offline. I mean, finished the code. And it's using a lot of my patterns that I use. So we have a model manager. And today the model manager is like a singleton in a way. And that means that we have this once log business and we have a get guy like this. And so this one is a way you get a model manager. You have only one for the whole system. When you start, there's only one model manager for the whole system. So we're going to do that, rather to pass it everywhere. We could, but we're doing these kind of things. And in fact, once we have that, we shouldn't need a clone anymore. Okay. And one thing is, I don't really like this way because it's confusing to me. I like to have a get model manager. Okay, so that is a function that basically use that guy and then create the instance. Okay, and it returns the error because that could fail. So now that we have that, this means that people can call this. Someone wants to have a clone somewhere. No function, okay, fair enough. So we say model. We're going to where I am. Okay, get model manager. Okay, so now we have that, and this is good. And we have this thing. So now it's not used. Yes. So what's happening is when we are doing the TUI, and we do hello, while sky is green. Misspell shouldn't be. It's not typical under normal conditions. The sky appear blue stuff. However, Green sky is usually silent. Well, I don't know why. So when we do that, what's happening here is, I'm going to clean up my stuff over there. What we do is, if you look at the TUI code, the TUI code will get, will send an action to a command to the executor, which is going to be our executor command, which is this one, and it's going to send run prompt. So that might be okay. So that is one of the things that, it's, do I want my TUI to write into the database the prompt and then to send, hey, I write this prompt? Or do I want an executor that say, people shouldn't know how to run a prompt and you send me the data and I do that. So that is one example where I'm okay to have a relatively big payload, because otherwise the rest I'm not sure is the right way I want. So that's good. Now, when it gets that, it does a business, and then it does this. And that is what we don't want. What we want, because then the UI is just waiting for the content and just see. What we want is to create a run into the database. And what we have done already is, if we go to the core, so if we go to the bus, the DB, and we have a DB setup, and that is where we are setting up the database. And right now we just have a run. So today, and this is what I have in AIPack, so I'm matching it today, I might change it later. But today what we're going to do is every time we do a run, we are creating this guy inside the MySQL database. MySQL is a gem for this kind of things. MySQL right now is only database. It's only backend. Sorry, it's only memory. So it's simpler. When it's not going to be memory, we might change it, might not be a singleton kind of guy. But right now it's only in memory. Right now we have UID and ID, and this one is a primary key. Later, I want just to have UID, ID being a UID, or call it UID, but I don't need both. And I want to be UUID v7 this way, which will have to be stored in blob. But if it's big agent, which is a normal way to display, to align it in a way, then the SQLite will index it well. So it's twice the size of 64 bytes, but then it's very unique, so we can split database and we can merge them, which you cannot do if you use sequential ID, obviously. So that's why eventually I want to use UID there. So now we have the prompt and now we have the answer. So that's my goal. This is my bookkeeping, is my best practice, my layer here, my CRUD-FN, and you can look at the source. It does this whole thing with modql, which extracts the things. There's a whole ninja tricks over there that allows me to add the prep field for update and the prep field update with where. So this is update. And so we prep the field for update. And here you can see that we add timestamp. So in this case, I know it's like, oh, I know that you have timestamp and I'm adding these guys. It looks static. It looks hard-coded, but it's fine because and that is awesome because the color that create doesn't have to carry this weight because it's part of the lower layer. So that is a way that I do timestamp. I do even UUID like that and all of these kind of things. That is a very nice way of having this timestamp business without carrying weight over. And then the way I have, and it's a lot of the same things that I have in my backend model controller. So this backend model controller, I carry it over like for the last 2 years in every project I created. And so in fact, if you go to run, so run, it's my entities, yeah. And run is one of the entity. And you have the run, which is the ID. So that is what will come from the database. So now I can read this guy. And this is just a wrapper type on top of I64. And that is where I use the macro rules attributes to have the scalar struct. So it puts everything that goes where. So if I go there, I don't know if this guy is not going to go where. Oh, wow. That's not too bad. Okay, that's cool. And so that is where my scalar struct will combine. So that is a macro rules. It's very cool in Rust. So now that we have that, I'm going to say that I'm going to say I have my executor. I just want to do a hack right now. I don't want to break the app, but I'm going to do a little bit. So I exec the event. And also that's my executor. And execute the chat. So that is where it does the handles the prompt. Okay, so he gets the run prompt, and then he handles the prompt. So what we want to do here is to create a new run. I'm going to put that in the database, in the SQLite. So what we want to do is when we do a new, and then this guy, okay, I'm thinking about where do I get the stuff. Oh, I have a start here. I can throw an error here. So I'm going to say let MM is my model manager business. And I'm going to say get model manager. Oh, interesting. Why I don't have that here? I should have that, yeah? I thought I had that. That's fair enough. Pub might not be exported from here. Fair enough. That is why sometimes I put the star, and then if I really want to be precise, but otherwise stuff. So now I get the model manager. So I get the model manager. Now this model manager is going to be a result. So I'm going to do a question mark. It works. I have the right guy. So that's cool. And I'm removing that. So I have my model manager, which is there. And now when I'm going to run the prompt, I'm going to, well, let's do it there. So we're going to do. Because in a real scenario, I don't want it to create the prompt right away. Yeah, so I don't know how I'm going to do the stuff, but right now I'm going to say, MM model manager. And that is this guy. And then I'm going to do run. So I'm going to create the let. So create exact. Okay. I'm going to create a run. So I'm going to do a let run for create. We're going to cheat a little bit here. So we're going to run create. So it's going to be a run from create. So we're going to import this guy. We're going to do field struct, and we're going to have that guy. We're going to clone it. And again, here I'm doing a little shortcut. I just want to make sure that it works in the database. It doesn't complain. So I do that. And why does this guy complains? Oh, option. Oh, that's not bad then. That's cool, actually. So create some prompt. Clone. And then here we're going to put none. And then the way that I always do my backend model controllers here, the way we update it, I don't like ORM. So I do a run BMC, which is backend model controller. So it's like a DAO in other guys. I'm going to import it, and I'm going to do a create. So there's a create there. And in this guy, is this? It's not too bad. And then that is not, because that is returning a result, an error of things, and a model error. And then this one doesn't have the model error, the from, so that's fine. So we go to execute this one, and we're going to do that is self, and then we're going to do a model. And then we're going to do a model error. And that is, we're going to do that. And we're going to do a from. So that is a derived more that I like a lot. Derived more, this one. And then you can do from, and then you can do from like this. So like this, you don't have to implement it. Beautiful. Now you go back there, and that should work now. So you create it, and then it will get into the exec and stuff. So that is another thing. Now there's a guy that complains somewhere. Okay. Yeah, fair enough, because we didn't pass the thing. So again, this one here, the way it does, it's a singleton. Usually I don't like this model, by the way. I like to have the states moved, the object moved, and then I put it in an arc. I'm going to do that like that for now. Later I might change that. Usually I don't really like it, but in my case, I feel it's okay, to do that. And in fact, I will do a get earlier on. I will do a first get model earlier on, such as it fails, and then it goes. Now, the trick here on this guy is eventually in some database, when you have a remote database and so on, first of all, you want that async. And then second, you want to have a way of retrying and everything. So you have to make sure that could be your handle. So it's fine. So anyway, all of that to say that I have the run prompt, I have the things, and then I create, and that should commit. So now if we see what this guy is doing the model manager, is taking the run for create, that this fields business, SQLite, not non-fields, that is something which is modql, which is a crate, the little crate I've created, kind of secret crate. ModQL is not, there's some people, actually more than I thought. So right now the problem is I need to do the 0.5 things. There was SQLite, but now you don't even need SQLite. So, but there's a whole thing about SQLite, which allows you to get data in and out. So here what we're doing, and that is the way I like it a lot, is we're saying the run C type, the run for create, is annotated with fields and SQL from row. So he knows how to turn that guy into fields. And he knows also to turn SQLite from the row. So if you have a row of things, he will know how to take a row of SQLite and put it there. So that is the macros here and that stuff. So now I have this field, but now the nice thing about this approach is that is a SQL field. And if you look at it, it's a vector of SQL field. And that is fully, very nicely dynamic. So then that's why then after I can add my own things there, which is my C time and everything. So this is kind of working very nicely. So now what I do is, what I do is the following. So we have the create, that create in the database and so on. And then I can do, typically what I have is let run ID. So that should return the ID of the run. Okay. create in the DB. That will return the ID of the run. Actually, this is going to be pretty cool. It's going to work nicely. And then I take that. Do I see? Yeah, you see it. Yeah. If I'm too big, you tell me. Then I take that. I take the run ID. I do the exec. This is send event. Start, run start. That is exec AI. Load file context, because that is part of the exec AI. Execute the chat. That is with my GenAI library. Then I get the result, yeah, from the AI. That's good. And then yeah, I don't like to have. Can I do something like that? I do the error. Can I do a question mark? Why can I do a question mark like that? Yeah, because the from here is weird. That is AI. I don't know why I had that. And then, so now my result is much friendlier. Okay, well. Okay. Okay, I get it. Because here I'm doing an error here. This one. Oh, okay, I get it. Well, okay, it's this way for now, and then we'll see. So I get the result over there. This is the AI that's running, I think. It's a little bit on a weird way. Because if it's here, it's always okay. That's a weird way. This is where sometimes with AI is. No, this I'm not going to do that. Why I will do that? Okay, and now I'm going to say I don't understand why I did this. That was weird. Ah, I get it. So like this, you can do that only once. Okay, well, we can do that like that. So I understand what the AI did, but it's not my style, but it's fine. Because this way at the end, it does this. This is why he did these kind of things. But then it's funny because he's doing this question mark, so that's not safe. But that will fail here. So the stuff was half-baked. I don't like that stuff. Yeah, that is. So this one is a good one to do, but the way that the AI did here was not good. But it's fine. We like AI. I like AI. So I do that, and then this one, I send the status. So that is where I don't want that. And we can have run and run and might have run ID. Okay? That would be cool. Because now people can listen and say, hey, if there's a run ID, then I will get it. But I don't want that. I'm going to keep it here because I don't want to break the beast, but I'm going to change it later. Yeah? So I process the AI response. That is ascend the status events. Obviously here, this one to do. And then, so there's a way, I had a pattern at some point. You know, all of these kind of guys here, what we want is we capture, and then when we run the exec, we want to make sure that all of these things get trapped, such as we can send that guy. This guy is very important to send. Yeah. So not this guy, the error. Yeah. So we want to. I'm sorry. I'm getting confused here. Sorry, guys. This is this one that we want. I had it in the clipboard. So I had a pattern, and I don't remember what it is. Actually, I should have put it in the Rust NX. But I have a pattern where I send all of this here. What we want is we create the run. In fact, there's an argument to say stuff, but we create the run stuff, and all of this where it could fail, we should put that in a function. We should do a try catch. There is no try catch in Rust, but there is something. So if I go to my Twitter and I do a try catch, I don't know. I have a pattern to do. It's always a pain to look at Twitter. It's my try catch pattern. I had a thing. Is that? Oh, that was back in the days where I was doing Swift. That was a long time now. Don't remember where I have. So there's a way with Clojure or something to have a neat pattern of try catch, such as we can catch all of these guys and stuff. I will try to find it at some point. I don't know where it is. Now I'm a bug. So now I'm like, I'm stuck on this one. So let's see. Rust, try, catch pattern with Clojure. Yeah, that is it. It's the JavaScript way, in a way. It's in JavaScript, it's the immediate function stuff. So I need to do a little things. So we're going to do that. It's pretty cool. I like that a lot. That is awesome. Now the trick is we might have a wait, which might. Can I go more? Okay, so let's try that. This is actually not bad. This is actually not bad. So we could ask AI to say, hey, do the stuff, but that is a nice pattern to have. So this one here, we're going to say, okay, if it fails, it's another beast in a way. But that, yeah. But then once we have the ID, then we can capture the error in the ID. So then everything else could go into that guy. Now, that obviously is something else. And that is that. And in fact, we have nothing. We have nothing. Yeah, I think we have nothing. We have something or not? Run ID, perhaps? And that, what we're going to do now, what we want to do is we're going to take all of that. And so the goal here is to be able to do that two guys, which is good, yes, because we have result answered and this guy, and then we'll have a catch on this guy. So if we do something like that, what we want is this immediate function. And we want to move all of that, guys. So why it didn't work? I'm going to be lazy here. I'm going to go back here. Yeah, that's fine. Do the syntax. Are you sure you can do that? Ah, not bad, not bad. Okay, so that was not immediate functions. Actually, I prefer this one. That is actually pretty cool. Async move. I'm not sure that that is not going to break out. If someone knows here? I'm not sure about that. I'm not sure. I'm not sure that that is not going to, this is not an immediate function. I'm going to ask our friend ChatGPT. See, it's funny. I think they messed up. No. That is not a function. Will return early from the async block, making the async block evaluate to error. Okay. That I'm oh, Yeah. Okay, well, okay, this one is a tricky one. I don't really like this one. Okay. So this is different than without that. This is why I was confused. So if you do that, I mean, here it will not work. But if you do that, a block, it wouldn't do that. But it's because it's async, then it creates kind of a closure or stuff or something like that. I don't know. I'm not sure. So this one is a closure. Okay, I get it. Hopefully, if you have a question here. So that is actually pretty interesting. So let's go there. And then we have that. And what we're going to do here. So now this is much better. And then we have this guy and send the error. And what we want is we process the AI response. Well, we're going to keep it like that. And then we're going to store. So now we're going to do that guy. And we're not going to do that guy. We're going to do the update guy. Yeah, that's fine. So we're going to do that. And in the run ID here, update, run ID. That's the way it works, the API. And that is run for update. That's the best practice. And then in these guys, we're going to have this. In that, we want to have none. So we just want to do that. We could do the default over there. And then this guy will be the answer. So it will be some answer. This is why I love Rust. Okay, so now we do an update. And if we look at the run BMCs, they all have the things. And it goes to the base update over there, which is a database. So what we do here is we have the model manager that has a DB guy. We have the ID. The ID is just a wrapper on top of I64. Later, it will be a wrapper on top of UID. And then we do the run for update. So this way here, this pattern allows you to really control the shape you want for the update and everything. This one is a little bit an advanced one, but that will go away because we'll have a UID only for IDs. And that is a run when you read. Yeah? So you can have different views. This is a video I did a while back. So now we have this, and it should be pretty cool. And answer, it doesn't like it because you're using twice. Fair enough. And then that's it. Okay. So now if we run it, there's still a little weird thing where it's not happy. Why it's not happy? Oh, it doesn't need the clone, I guess. Okay. So now if we go back to our terminal, and we're going to do a cargo run. Now it works very beautifully. Is purple. Oh, why is sky purple? I don't even understand. Blue, blah, blah, blah. So I'm using light, so that's why it's very fast. So now the cool things about that, it didn't complain. So it's probably fair to say that it got stored into the database. Now, the reason why it works is because when we do the run result here, oh, why? Oh, I lost my brush. Okay. The reason why it works is because we have this run result, and the TUI is waiting for the run result kind of to display it. That is what the TUI is doing. And then we send the run stuff. So we should send here the thing that is happening is we're going to keep that. So git AC, and we're going to use that practice when it still is work in progress. Okay, work in progress. Wire model to the executor and TUI. So this is what we're working on right now. And I have 30 minutes more to go. So we're going to try to do stuff there. So now that I have that, what I want is to update the database. I want to have the TUI that will listen the event, the model event. That is what I want. And so the way we're going to do that is I'm going to have the TUI and the TUI loop. So I want a guy that feed that guy, okay? And for that, I need a model loop that loops through the model. Yeah, because I want someone to send that. And I don't want those guys to know TUI. That's not the goal. I want this guy to know model or core and say, hey, I want to subscribe to your event. So what we're going to do is we're going to have another guy here, which is a model loop. And then a model loop. And this guy will go get the model events and then feed it into my normalized app event. Yeah, the app guys. These guys. Yeah, that guy. So that is what we're going to do. Now, we could do that by hand, but I'm going to give it a shot to try to do that by add C and GC, and I'm going to wire work in progress, wire model event to TUI. And then I'm going to do a W, and then I'm going to run my my AIPack Pro, so that is a pro coder, so for the prompt. And that's my best practices. This is my crates. It has a source. We're using Flash stuff. We're going to do our friend Flash today. Is a good one. This one, this one is more expensive now. So I'm going to do a mini high. I think that should be good. And then, so that is ChatGPT. And this one is the new Flash. So I've updated AIPack. So the way it works here with ProCoder is it will do an auto context to find which file do we need to use. And then with that model, it will do a code map with that model. It's very fast. And then it does the work with that model. So now I'm going to do a workbench. So that is where I'm going to put the discussion over there. I'm going to turn the chat on, and I'm going to say, look at the ZC core model and the broadcaster and wire it to the TUI in the model loop and send it to the TUI event TX with the TUI TX. Okay, capture this ask and give a summary of work done. I'm going to try to do that in one go. We're going to see if it's good, and if it does it in one go, that's going to be pretty impressive. And actually, you know what? I'm going to keep, to be fair, I'm going to keep Flash here. I'm a little bit mad that they want more expensive, but stuff. So what we want here again, what we're doing here is this guy. So if I go back to the architecture, we have a TUI. Zcoder is going to be a terminal, a CLI, a coding harness, which is going to be parallel first coding harness. Is going to have a TUI, so that is a crate. And then we have, let's make sure. And then we have the core, which is going to execute the work. And so what we want here, if I do actually this guy, we have the model event over there. And so we want the model event to broadcast. So the exec command comes here, it does the work. Today the exec event come back here, that's fine, we're going to keep that. But then when this guy is going to create the model, then the model is going to broadcast. And we have a broadcaster here because we might have different listeners. So that is the way it works. Yeah, so the commands go there, and then this one, create that, run the AI, update the answer, then every time there's an update, this one triggers. So that is what we want to see. So if I go back there, it's done. So that is the Procoder AIPack, and this is what we're going to port into zcoder. So that is a generic UI for any running any type of agent, and there's an agent that is Procoder. So that is what I'm running. And it has a workbench context already. So all of this workbench and stuff, it's something that is already very well tested and better tested in Procoder. I'm putting it in zcoder. So now I'm going to see that. And this is run model bus. This is pretty good. This is not too bad. I don't know why that is. Yeah, we're going to. Okay, that's fair enough. So what does it do? So what does he do? Funny, it's just modified that. Okay, fair enough. Wait. Result. Yeah, okay, we're going to do that. Something like that. So here we'll do trace later. That's good. So we have the run model loop. He subscribed to the model bus. He gets the model bus. He gets the things and stuff. So that is pretty cool. So now this should be called from a task. And I think we're going to call it on the UI. And I'm trying to think. TUI, we are going, I think that would be the nice place to put it. We start the TUI, we do the things, and we're going to do that guy, which is run model loop. And we're going to see when we have the TUI TX. Beautiful. Run the model loop. And that will do a run like that. Okay, sorry. And I need to do a Tokyo span, yeah, because we want to make sure that needs to have its own task. And we're going to have, so we need to clone, yes, we're moving it. So we have the TUI TX. So that is multiple. Yes, MP, multiple producers, which is a TX. Single consumers, which is this guy. So we want to call this. We're going to say for model. And that will be for exec. And then I'm going to have this, and I'm going to say run model loop. That, and I'm going to put that. Okay, that's fair. And we do the await. Okay, that's it. So we run the model loop, and that will run it, and then it will send the event over there. Now, we're not doing anything with the event, but hopefully it won't break anything. So now we go back to our terminal UI, and I'm going to start a new guy like this. This is tmux, okay? So now I'm there, and I'm going to do a cargo a keys to have my API keys and cargo run. And this cars, depends how many cars. Okay, so that is good. And so it works, but we don't know if it's really doing the thing. So I'm going to do a git log, git amend. And so now the way that I will do my boost is the following is, and I'm looking at some my stuff over there. I'm going to go to my main. And here is what I have. I'm going to set up that guy. So I'm going to set up the tracing, such as we can trace a little bit the events, because again, we're building a TUI, so we cannot print. So we can either do, which is not a bad idea, but kind of a TUI within the apps, having a little, panel somewhere where we see the log, which is not a bad idea. Or we use tracing, and then we trace the stuff. So we're going to do the tracing business. So we're going to do, for the tracing, there's two parts here. The first part is you go to your root main. So again, we are in a multiple crate guy, like that. So we have multiple crate, we have this crate, that crate, and that crate. We want to put the tracing listeners and writer in the main code source, and then these guys will send events to it. Yeah, so that is the way it works with tracing. So we're going to, in the main over there, we're going to trace it, set up the tracing. That will be zcoder / trace debug log. Debug log. Okay. And then there's all these kind of things. And the debug log here, the thing I like to do, I'm going to, that is a little process that I have that works very well before. So I'm going to follow that. I don't want it always on, so I have this on-off business over there. And then later I can make it better, but this works pretty nicely. And then all these guys, I have the right tracing business. So give me a sec. That is what I use for tracing. So I go back to my main guy. This is my dependencies. I like to have all the time now, I have my workspace dependencies like that. So I'm going to do, well, trace could be almost above. So I'm going to do that. Now, for the main, so that is my main, is the cargo of this one, which is this guy. So this is, and I put it below, before, I think, so I'm going to respect it. And that is workspace equal true. Okay, so that is what I'm going to use. And then I think I just need that, I think, on the other guys. I'm not 100% sure. So up, we're going to add that guy, the event filter guy. Now the event filter, I need to have zcoder, debug, UDFX debug. And now the problem is, I never know if it's a ZC TUI or is it dash. I'm going to say it's underscore. Okay, we're going to go with like that. So hopefully that will work. And then ZC core. And then we'll add the command. So I think that is the two guys. And then on the TUI, we're going to go back there on top to follow the order. We're going to do trace. And then we have the tracing. And now, if I go to my TUI business, go to my TUI loop, and I'm going to do a debug. TUI got model event. And we're going to do a model event like that. This is a little bit heavy, but once I have that, it's pretty good. And then I do that. So I do that because I'm going to delete this line later. So I don't want that. I don't want to import it because I'm going to delete it. It's not something I want to stick around. When there's something to stick around, I just import debug. So that is my best practices a little bit. So now if we do that, I don't know if it's going to work. If it works, it's pretty cool. Compile, so it works at 90%, I guess, with Rust. So we're going to do a cargo run. Now we're going to do something like that. And then we're going to do .zcoder, debug log, debug that stuff. So far, so good. And then we're going to do a tail-f. And we're going to do zcoder, debug log, log.txt. Okay. Mouse bigger than elephant. Question mark. Oh, look at that. Model event. We got two events. And this is beautiful. And in fact, we can do a little bit better to format it better. Can go run. I don't have any idea anymore. Is Gemini better than OpenAI? Like the run created, and then boom, cron updated. This is awesome. So now the next step here, that is going to be very good for today. This is actually very cool. And that is SQLite. That's many stuff. So now the thing that we're going to do in the next episode, episode 06, is what we don't want is the UI again. You know, if we go back to the executor. So again, we're making a terminal UI here to do AI parallel first coding harness. And we have the TUI that send commands. So this guy, they send commands to the executor. The executor does the job. And today, the executor sends the event with a payload. We don't want that. You don't want that in the web UI. You don't want that in UI. That's not the way it's supposed to work. I mean, at least the way that architects stuff. Command comes, goes back here. This guy goes to work, updates the model. The model broadcasts to say, hey, this data at this type, at this ID had changed. And the UI say, oh, okay, I care about it. And then if he cares, he goes and read the models, and then it displays it and keep it in the cache. This is a way to do it. Yeah? So this way, the status here, we could use it for some stuff. I'm not saying, but it shouldn't have any payload. Yeah? It's just exec event. So that is the thing which is important. So again, I think I was drawing on my own screen. The exec come this way on the command, and then he say, hey, do this prompt and stuff. This guy is going to do the job. He's going to store it in SQLite. And every time he updates SQLite, our model layer, you can see at the code, broadcast events. We are using a broadcaster because this way we can have eventually a web that will listen to the same guy. Yeah? So that is the way you do it. So in fact, the model events, they are in the arc to make sure we don't duplicate them. Yeah? And arc is very efficient. It's plenty efficient for what we need. And so now I can broadcast these messages. And so now the UI will listen these messages and we say, oh, do I care or not about it? And it will look at the ID. Yeah? So it's the type and then the ID. And the TUI say, well, yeah, I have this guy. And in fact, we even have a trick, which is related ID, because the related IDs allows us to say, well, I am on a task, but my related ID is this run ID. And then these guys say, well, I'm displaying this run ID. I'm not really sure if that will impact my UI, but to be safe, I'm going to re-render. And that collapses complexity a lot, because then you don't have to have the UI being too smart. And it can just refresh when something related to what it has in the screen changes. And again, this is, you can reduce the complexity. So the cool thing here is that what we did, and I'm actually pretty happy, is exactly the way I would have coded. Yeah, is I didn't break the flow, but now I do the event like that. And so again, here you can see the events. Oops. The events that are coming, they don't have the payload. They just have the ID. If there is more than one model event in the message queue, does the TI layer, yes, so this is very interesting. All the message in one go or stuff. So that is what happened in AIPack. In AIPack, you have this code map. This code map can have thousands of tasks. And the problem before is I was listening all of the model events, and so the UI was very slow. So what we did, and we'll talk about that, I will do another video about that later, is one way to solve that is back pressure, is that you slow down the worker because you are too dumb to go fast. That's not nice. The way that I've done it in AIPack, which is these things, and Procoder will do that, is when you get all these events, you will see that in my event over there, I have this guy, a TX command. So that I normalize my MPSE. We're using Crossfire, but here's the power. The power is in my receiver, I have a try. So receive await is going to wait. But try receive is going to see if there's something already there. So in fact, I debounce the message on the TUI. I loop before I redraw the whole terminal. I don't do that today. I do it in AIPack. You can see the loop in AIPack. I go into this guy and I get all the events. Sometimes I can have 400 events or 200 or 150 or whatever. And then I go and then I debounce them. And usually I go 150 to like few, because in fact I say, oh, I need to re-render anyway. So I re-render, and then the render knows how to get the data. So then after I say, okay, I need to render this guy, And so I know which data I need to get. And so then I have one call for 300 guys coming in. So that is where you can have back pressure at some point, but what you want is debounce it on the UI. And so that's why when you have an event-based kind of things like that, it's very important to implement. And they all implement that. Yeah? So that is why using Crossfire, this try thing, because that is immediate and you see if something is already there. And so that was the trick to scale. And we're going to do the same thing. So you have a UI always up to date, very responsive, but that doesn't get overloaded. Yes, the model event doesn't provide the payload. This is very important. I mean, at least in all my design, I always provide this. Now, what you see, that is a magic. Because when we are going to have more data type, it's going to say, hey, here's my related IDs, not my children usually, my parents. Yeah. And I don't really need to know if it's my direct parent or the one above, but I have one ID pair related entities. And it's just one because it's usually a parent, one too many. And that allows the UI to say, well, I don't know, but I have this parent. I have run ID. So, probably one of my view will be interested as what's going on. And then it display it. But when you debounce it, you debounce the event for the run ID. So you can actually debounce everybody for the same run ID. So the TUI can be smart enough to say, hey, I just need one pair run ID. Then that's it. So there's a whole trick over there. So this is what I've added in the AIPack, and this is like magic. So now you can actually have event without back pressure, because at some point people were all excited about back pressure. It looks smart and stuff. Problem is you slow everybody. I mean, that's mean. Like, be smart. So that is what we're going to do, and we'll do that. So that's why it's very important to have this kind of thing. And this is why here in Crossfire, I map the error, because they say that if try, it's an error if it doesn't find. And I say, no, if it's empty, it's not an error, just return none. Yeah? And then you go back. Yeah, the workbench, if you have several workbench in parallel, yes. And that is where it gets tricky. It's like at some point, you want to say which workbench I'm watching right now. And then in the loop, you will do that per workbench, per entities. So there's going to be, I'm going to do that later for now. But yes. So now the cool thing is we have these guys that works very nicely. So what we're going to do is we're going to commit that. So I'm going to git log. Well, you know what? I'm going to amend that. I'm okay. I'm amending that other stuff. Hey, Void. Well, I didn't expect to catch it. Just woke up. You guys, you work as much as I do, man. So, because it must be very early for you. So anyway, so today, okay, let me tell you what we did. Today we did some pretty cool stuff. So we did that. So yesterday we did this guy, yes. We did this building of the event model and the data store, remember? And I started to do the SQLite and everything. So that was a video of yesterday. Then offline, I fixed all of my patterns and everything because I have a lot of patterns. So I fix it and make it compile and I push it to main. And then today here, I wanted to solve these things, which is from the event, from the event to the executor to the model store. And we store it in SQLite. Because today, the way it works, and I've added a little bit some drawing here to show the stuff, is today there's the exec command. So I rename a little bit, yeah? So there's a command that comes from the UI to the executor, which is good. Which I run this prompt. Then the executor does the AI stuff. And yesterday, what he did is he sent back, even today, he still sent back the event there with a payload. Payload shouldn't be a message business. The payload of the message should just be the IDs. That is what I like to have. So rather that, what I do is now the executor is running his business and now he's writing into the model layer. And so we are calling it a run. When you ask to do a run, like going to AI, that is a run. So it's a run object that we have in the store now. And then this guy has, and so Crossfire is good, but Crossfire doesn't do broadcast. Yeah? We could implement our own broadcast with Crossfire, but we can reuse Toko broadcast. So now the model, every time you update or something, it broadcasts events. This model events, obviously the inner is inside the arc, such as it's efficient to send. And then we can have multiple listeners, a TUI being one of them. Now, this guy here, later, if we have a web UI, it will listen to these guys as well. So the command can come from anywhere. It doesn't matter because people will listen to the model event. Because that is not really, it doesn't matter that much, the status of the executor. We might, and that might become a broadcast later, I don't know. But right now, it sent the payload, which was bad. So what we did is, we did that, and we wired the TUI to run a model loop that read that guy. So that is what it does. Okay. So now what we did here is, you see, I have a tail.f over there. So I put the tracing. And so I'm going to clean the tracing, it traces there. So in main, I have the thing. And now in the executor, when the executor takes the prompt, he handles the prompt. Now he gets the model manager, same stuff that you do, xvoid, with a backend model controller, same business. This one is a static one today. Yeah. And then it takes a prompt, then it creates a run. So we have this run database inside the SQLite. Yes. It doesn't know anything. So we did, and that is the reason, the core doesn't know anything about TUI. And the model is inside the core. So in core now, we split nice, we have model and executor. That is the executor, that is the model. And so the goal here is really that later, I want to make sure that I can have different UI anywhere. Okay, so this is, if I want to have a TUI or a web, or it could be Tori, it doesn't really matter. The core can be run. Yeah. So that's why I want, when you send a command, anybody can send the command to the executor. It doesn't really matter. And then it goes to the model and people listen to the model event. This one might become as well a broadcast. And again, always with the ID and stuff. And then people goes back and ask, the core about the things. The way to ask about the model is to go through the model manager. And one day we might have an executor, if people want to query the executor, I don't know. Yeah. But that is a way. I'm going to try to keep it, everything stays there. So that is nice because then it's fully decoupled. And the core has no idea of what a CLI is. So that is the goal. And this is why before what we did is we split the TUI, sometimes people say it's upstate. It's not upstate because it's not your data store. It's only what you see. It's like a video game. Yeah, you compute what you see. You don't compute behind the building. It's cute. Steve Jobs does that. We don't care about the fence. So the thing I'm saying is to say that the goal here is to, the TUI state is to really cache. And it has to cache because otherwise it gets slow after a while. In some case, but cache what it thinks it needs to display what is in the queue. Yeah. So the TUI needs to say, well, I'm running this workbench, or this chat, or whatever. And so when something happens, I need to display. And then we debounce it on the UI. This is what I do in TUI. So hopefully that answers your question. And then in the guy here, if we do a cargo run, so right now we still do the ugly guy. Yeah, view on the model, yeah. Projection of the core model, yes. And then there's like since Xvoid, since you're like on top, you're always if you this in AIPack, this is the thing here in the TUI core. So it's a mono. I didn't split it early enough now, so it's kind of a mono crate. I regret a little bit on the AIPack, but on the ProCoder, I do it the right way. So that is AIPack, it's not zcoder, yeah. And so in zcoder, we're going to do it the right way. But here is the magic. So a lot of the pattern is here because a lot of work. But this is the guy here, debounce event. And so I can take many events, and if you look at the debounce event, it's going to debounce the stuff. And so there's and it takes the first step. Because this way it has to take the first step. So there's a whole trick here to make sure that you get a first step, and then you do a try receive to see if there's stuff in the queue waiting. And if not, you move, and then you process, which is you debounce. And then depending of the type, you debounce it, and then you add it to the debouncer. And the debouncer has all of the things by tick event and all these kind of things. And then it can decide what, if it needs to redraw and what type of things it needs to do. And that is magical because then you reduce 100 events or 200 events in one or two. And then the UI is super responsive. So that is what we're going to do in later. Yeah, but right now, I'm not there yet. Right now, the cool thing is, you see, I had this, and because now the executor updates the model and everything, but it still sends a message to the stuff. I say, I don't remember what they say. Gemini, better than Anthropic. And then you see, boom, model event, model event, model event. So that is arc, yeah? And then I have this guy, and then I have the, so I have the update here. That is the update. Sorry, updated. And then the other one was the created. And always with the ID, not the stuff. So then the TUI will go on back to the server to display that. Okay, hopefully that makes sense. So that is working beautifully. And now what I could do is to say that when I handle the prompt, so I'm going to go to the TUI. What time is it? Nice, sorry. You will have, yeah. So one thing I'm going to have as well, you're right, is Xvoid. For my SQLite stuff, I don't know if you do SQLite things, but for my SQLite, I'm going to, let's go back to my model. And in fact, Xvoid, I'm going to do that as well. No, it's good, it's good. Even for web backend, Xvoid, I'm planning to go UUID v7 everywhere, even in Postgres for IDs, because the value is you can split and merge database. So it's huge. And it index well because it's v7, so the first 40 bits or whatever it's time. So it buckets well. So if you go to run here, today I have ID and UUID. So that's my DB setup. But eventually that will go away and it will be only UID or IDs that will become a blob. And so that's my goal. That will be another one. I might have AI doing this guy once I have the design, updating the stuff, but that's going to happen. SQLite. I mean, I'm the biggest fan of SQLite. No, it's not for everything, but it's awesome. I mean, and for ClearApp, it's no brainer. I couldn't have done AIPack without. And so that, and we're going to do quite a bit of SQLite because it's going to be different things. So anyway, this is the thing, and then. What we want is you can see that this guy is sending stuff. So we're going to look at the TUI and the state processor. I have this stuff. All these guys in unused. I don't know why he wrote that at the time, but TI base, I have a model loop, ping time, the term reader, a cool, and app event handler. Okay. So that is run start, sending to AI. That is this guy, set lat answer. So that's good, yeah? So look at that. So I'm going to do something like this, just to make sure. So that is a string, and I'm going to do let answer, and I'm going to do something like that, format an answer. Okay, just to make sure that that is the guy that we see, which I think is the guy that we see. But I'm being safe because here, set processor, that doesn't make sense. So I'm going to go there, I'm going to do a cargo run. Anthropic better than open AI, question mark. Then, okay, so I have this. So now what I'm going to say is I'm going to say I don't want that. Okay. And my hub, so I'm not listening to the stuff, I'm listening to my model event. That is where there's a thing in the name here that I'm not super happy. Okay, here it is. And this one hopefully takes a state. Oh, that's not nice. Oh, yes, takes a state. Good. That needs to be refactored. It shouldn't be all there, obviously. But I should have a model somewhere, no? Yeah. So what we've done here before, Xvoid, we did that. We did the run model loop. And now we're sending it to the model. And we're starting it when we start the stuff here, the run model loop. So now we have this loop running to listen the model guy, which is a broadcast. Okay. So that is what we have. And then my goal is to go to that guy. Here we do nothing, but now I'm going to go. So this is where, honestly, it's a little bit on the, I'm not. Get model manager. It's a result, so that's good. I might have to implement the stuff, but that's fine. That is a get com model, it's fine. Okay, cool. I already had the stuff there. So the from this error, so that's good. We have the MM over there, model manager, that's my stuff. Same thing as a web server, doesn't change. There's not a big difference between, when the architecture is right, it's about the same thing. And then that works pretty well because we did the trace debugs over there. And now what we're going to do is we're going to do model event. So we're going to assume it's run ID, okay? I'm going to be lazy. It's run. So I'm going to do let run ID equal model event. Oh, this stuff is annoying. Model event. I'm going to assume that is this guy. Oh, okay, now it's I'm mad at myself. Match model event dot entity type. Entity. Well, it's not that hard. Okay, and then on this guy, okay, and the data, the model is going to change, yeah, but the stuff. I had a massive technical issue with responses so not so long ago. Yeah. It's the debounce. Yeah. So it's not only, you don't want only to back pressure. Back pressure is cool. It looks good on the books and on YouTube, but is you want to debounce on the UI side and treat your UI, your TUI as a video game, like a game engine. Yeah. It's all about computing only what you need to see. You cannot really know everything you see, but there's some heuristics that you can do, and then you make sure that you model events. That's why I added real IDs. Related IDs, because then you can do that. So now I have this, okay? So that should be pretty nice. Okay. Now I have, so I don't want to break the loop. This is where I'm not happy about having this like this, because I don't want the loop to break. So that should be in a function. Yeah, that should be in a function. So I do a run ID event, and then, so that is the option ID. And I'm going to say if let sum, far so good. And then I'm going to do a model manager. No, not a manager, a run BMC. And yes, it's okay to have the TUI accessing that. You could have a TUI layer if you want, but it's okay to have this. Now, ideally, you will make sure to not expose the write the same way as you expose the read, but that is something else. So I'm going to do a run BFC, and then I'm going to do get run ID. And we're going to, let's put this way here. We're going to use let change stuff just because I'm lazy. I don't want to. We will handle it better later. Why it doesn't work here? Should work, no? Okay, good. And then, fair enough. Beautiful. So now I have my run over there. You have to love Rust. This is awesome. Now why not go to handle 0, or we can say, we can debug. Okay. And oh, because I don't have. Yeah. So why it doesn't? Oh, why doesn't? Why doesn't? I'm confused. Getting tired or what? Okay, so why didn't? Oh, interesting. Oh, it did the wrong guy. Okay, debug here, and then this guy, and then I'm going to do what the other guy was doing it somewhere. Beautiful. And because I don't, yeah. That the Meslo font, that is a good question. I think it's a nerd font because I'm a big fan of the nerd font now. And I can open that. It's open source. I mean, it's open source. I put it on Git, yeah. So there's if you go to Jeremy Sean GCZ config, and you get the task and everything. And then the font that I have is what is my font? Oh yeah, Meslo, yeah. Meslo LGS. Oh, you're pretty good, man. That's next level stuff. So okay, so that is good. And then we do a cargo run. And then I say, why is guy black? Oh, funny. Oh my God. That's it. So that means that now I can go back here and I can say, you know what? I don't want results anymore. This is not a thing. And this is, could be a thing like that. Yeah. And it should be a run ID. That is what I will do, yeah, because now it's to say, hey, that's the exact, I'm running this guy. And, you know, you could say, well, you know, but that's fine. I think it's good stuff. Now, that is going to complain a lot. And tx send, and look at that. And the run ID is copy, so I should be that. Beautiful. Then I go back here and I say, hey, this is not a thing anymore. That is a thing. And then the run error, that's not a thing anymore. That is a thing. Then what I will do, every time I say I stop and then I don't, I will go back to 4, guys, the top 4. I'm going to go back to my DB over there, that guy, and I'm going to say error. That's fair enough. Text, that's fair enough. And then we'll go back to that. And before sending the event, that would be nice. I'm going to do yeah. No, not run BMC, update, run ID, and then I'm going to do a run for update, and then I'm going to have an error, and I'm going to have a sum error, to string. Yeah. Now I go back this guy. Up. Default. Now I go back to this guy. I'm going to add that. I'm going to add that to my run guy over there. And then, what does everybody cries here? That's fine. Under status. To AI, and that will be a run okay, that's fine. And then run status. This is not a thing anymore. And that shouldn't be a thing anymore as well. Actually, I don't know if it should be or not. No, actually, I think it's good to have. Okay, so let me go there. So ID. Right now I'm lazy, so I'm going to do. Well, yeah. So I will go and get the error over there. And then that's it. And that is as good as it gets. I mean, that's good. Still a lot of stuff to do, but if I do a cargo run, why is sky yellow? I didn't do the yellow. Run 1, awesome. Oh no. Oh, yeah. It's because it's slow. Yellow kind of making him think. That's pretty cool. That's it. That is pretty cool. Git log, git amend, and I'm going to merge these two guys together. I usually use fork to merge that. And I'm going to do a git commit amend. A new model event to TUI. Well, today, and thank you, step 1, thanks to you, I got it. I was almost lazy tonight. I was like, hey, I should do it. GPO, boom, is over there. You can play with it. And so today, I think we did a pretty good work. It's kind of 3 guys. I don't know who it is. It's Xvoid. Awesome, you're back. I mean, to have you on the morning. And then step, okay. I think we're the 3 of us. There's one more guy. I don't know who it is, but you are very brave if you started from the beginning. And then until next one, happy coding.